Imagine tying thousands of helium balloons to a human being. Would they actually lift off the ground? Or is that just movie magic? At first, it sounds ridiculous. A balloon is tiny, light, and fragile. A human is heavy, dense, and definitely not built to fly. But once you start doing the math, things get very interesting because balloons actually can lift a person, and just not in the way most people imagine. Helium is lighter than air. That means every helium balloon creates a small upward force. One balloon doesn't do much, but thousands of them add up. By itself, that force is tiny, but when thousands of balloons work together, those small forces start turning into something much more powerful. One balloon barely lifts anything. 10 balloons, still almost nothing. 100 is better, but nowhere near enough. You have to think in the thousand. That's why this idea only becomes interesting once we stop thinking in single balloons and start thinking in massive numbers. So let's choose an average adult weighing around 70 kilograms, about 154 pounds. It's not a perfect number, but it gives us a realistic starting point for the rest of the calculation. To figure out the total number of balloons, we only need two things: the person's weight and the lift created by one balloon. Once we have those two values, the rest of the problem becomes much easier to estimate. A standard helium balloon does not lift a kilogram, not even close. Its lifting power is actually tiny, and that tiny lifting power is exactly why the final balloon count ends up being so extreme. Now compare the two. On one side, a 70 kilogram person. On the other, a single balloon with almost no lifting power. The gap is enormous. The only way to close that gap is to keep stacking more and more balloons until the lift finally matches the weight. And this is where the number starts exploding, because you don't need 10 balloons, you don't need 100, you don't even need 1,000. At that point, we're no longer imagining a bunch of party balloons, we're imagining an entire lifting system. To lift an average adult off the ground, you'd need a truly absurd number of helium balloons, enough to form a giant floating cloud above you, and visually it would look much more like a floating balloon cloud than a simple bunch tied to one person. For a 70 kilogram human, the answer is about 6,900 helium balloons. That's roughly what it takes to actually lift an average adult off the ground. And yes, that number is way bigger than most people would guess before seeing the math. And of course, if the person weighs more, the balloon count rises fast. 50 kilograms would need around 4,900 balloons. 90 kilograms? About 8,900. At 120 kilograms, you're getting close to 12,000 balloons. Even small changes in body weight can add hundreds or even thousands of extra balloons to the total. So yes, in theory, balloons really can lift a human, but that doesn't mean a real-life flight would be simple. Lift is only one part of the problem. The moment a person actually leaves the ground, you have to think about wind, balance, body position, drift, panic, landing, and what happens if the cluster moves in the wrong direction. Suddenly, this stops being a fun thought experiment and starts looking like a very dangerous engineering problem. That's why a real attempt would need much more than just balloons and string. You'd need a proper harness, secure anchor points, weight distribution, safety gear, and ideally a controlled way to come back down. In other words, if someone actually wanted to try this safely, they'd need to treat it less like a prank and more like a miniature flight project. Then there's the size of the balloon cluster itself. 6,900 balloons would not sit neatly above one person like in a cartoon poster. The cluster would spread out, pull in different directions, and occupy a huge amount of space. Depending on the size of the balloons and how tightly they're packed, you could easily be dealing with a floating mass several meters across, something closer to a moving structure than a bunch of party balloons. So how high could you actually go? In theory, much higher than most people expect, but in practice, altitude would depend on weather, temperature, balloon volume, total payload, and how much lift remains after the entire system is assembled. A calm day might let you rise gently. Strong wind could turn the whole thing into a disaster. So the real answer isn't one number. It's a range controlled by conditions. And that's why I love questions like this. They sound ridiculous at first, almost like a joke, but once you start breaking them into forces, mass, lift, and gravity, they become surprisingly serious. The impossible doesn't disappear, it just turns into math, physics, and a much clearer picture of what's actually going on. And if this whole topic feels weirdly old school, that's because humans have been fascinated by floating flight for a very long time. The first manned balloon flight happened back in 1783, and from that moment on, people have kept experimenting with lighter-than-air flight. So even though 6,900 party balloons sounds absurd, the dream behind it is actually centuries old. So the final answer is yes. With enough lift, enough balloons, and the right setup, a human really can fly away. But the fantasy version is much cleaner than the real version. In reality, it would take thousands of balloons, careful planning, safety equipment, and a lot of respect for how unstable the whole system could become. It's possible, just far more extreme than most people expect. And here's another way to think about it. 6,900 balloons doesn't just mean a lot. It means a full-scale floating structure built around one person. At that point, you're not dealing with a fun party trick anymore. You're dealing with something that behaves more like an improvised aircraft than a bunch of balloons. It also shows how sensitive the whole idea is to weight. Add a backpack, heavier clothes, or extra gear, and the balloon count goes up again. Even small additions matter when each balloon only contributes a tiny amount of lift. And that's probably the biggest surprise in this whole experiment. The answer isn't yes or no, it's yes, but only if you scale the system to an almost ridiculous level. That's what makes balloon lifts so fascinating. It feels impossible right up until the numbers finally start making sense. If you enjoyed this video, let us know what we should calculate next. A sofa, a car, a piano, a house. There are plenty of objects whose parameters seem impossible to calculate at first. But honestly, that's exactly what makes videos like this so great. We have so many more interesting and educational ideas in store. It's only going to get more exciting from here. Thanks for watching. Subscribe to the channel, hit the like button, leave a comment, share this video with friends, and grow with us. If you enjoy videos like this, stick around. There are plenty more absurd questions ahead that are worth turning into real calculations.